So hi, my name is Mama Afisaman bin Sham. I'm from J4EM 1103E and I'm going to show you grinding process. Okay, so now I'm going to show you the safety before we start experiment. So the first one, we need to wear a glove. Okay, so we need to wear a glove because the glove is used to protect our hand. So we wear the glove first. So the next one, after you wear glove, you need to wear a mask. So this is to prevent dust or we breath dust or toxic gas. Okay, and the last one, we need to wear a safety goggle. So this is to prevent something get into our eyes. So that's all safety before carrying the experiment. Thank you. Okay, for the discussion, the first question is what is the purpose of etching process in the preparation of metallographic sample and how is that? Okay, so it is to reveal the microstructure of sample that has undergone several process. Okay, the etching process is done by etching the sample in the fume hood machine and leave it for a few seconds. After that, the sample is rinsed with water and dried using dry air in the fume hood. And finally, the microstructure of the sample is observed under the metallurgy microscope. Okay, for the second one, describe the heat treatment procedure for steel, which is annealing, normalizing, quenching, and tempering. Okay, and the intended final microstructure. Okay. For the first one is annealing. Okay, for annealing, the sample is heated to a certain temperature and then the temperature is held for a few seconds and then the sample is cooled down slowly. Okay, so this is to achieve the microstructure for arsenite microstructure. Next, for normalizing, the sample is heated till above the critical temperature and then it is cooled down outside by air. It cooled down outside by air. It is to achieve pearlite microstructure. And the next one is quenching. So quenching is the process when the sample is heated to a temperature that is sent to arsenite range, which is quite high, and then the sample is cooled down rapidly. And this is to achieve martensite microstructure. And the last one is tempering. Okay. So the sample is heated to below its critical temperature and then cooled down by air and is to achieve bainite microstructure. And for the last question, C, briefly describe the characteristic of martensite microstructure. Okay, the martensite microstructure is needle shape. The first one is needle shape And then the second one, it is brittle, and the last one, it has low density. Okay, that's the three characteristic of martensite microstructure. Okay. The next one is conclusion. To conclude the result of the sample that I have observed under the microscope, it shows that the sample has ferrite pearlite microstructure after the heat treatment process. This is also proof that the steel mechanical properties can be changed through a heat treatment. Every single steel in this world have different microstructures. By doing this heat treatment, we can observe the steel mechanical properties to their microstructure, whether it is pearlite, ferrite, martensite, bainite, or the combination of all these four. That's all.